Go.
Good morning, everyone. Welcome to SIM 315, Optimizing FIM. We realize that this is the last day of the conference, and it is the first session of the day. Thank you for making the special effort to come and join the talk. And in return, we hope to make the talk interesting, and more importantly, give you some nuggets of information that you can take back and imply on your daily work. And I am Arshad Ahmad, the lead program manager in Forefront Identity Manager, and with me I have
Mark Wall, and I'm the architect for Identity and Access Management.
And today, what we are going to talk about in optimizing FIM are 4 areas. These are the areas that we've heard from our customers from various sources when we talk to them at partner meetings, customer meetings, when they call into CSS. And in each of these 4 topics, what we are going to do is going to tell you some of the symptoms that will help you identify if there is a need for optimization in the space. And then we will go under the covers, we'll peel the onion and tell you what is the system and how does it work. And once you get an understanding of how the system works, we'll roll back up and tell you the recommendations of how you can actually go about identifying the issue and perhaps resolving it. In case of some of these cases, we'll give you recommendations, and for some of those recommendations, we will also tell you how to actually do the task. So what we've done is we've sequenced these topics according to the FIM product stack. We start out with the FIM service layer. We talk about service partitioning and the workflow hosts. Then we move on to the area of how FIM service interacts with the database, and we specifically talk about search and search scopes. The next thing we do is we fall down to the level of the FIM service database. And in there, we will talk about system objects. What is it that creates the system objects? What is it that grows it? And how you can help optimize the system objects within your system. Finally, we wrap up the talk by talking about initial load. And that is how you prime the pump. That is how you get your data into the FIM system. And getting a background on how some of these systems work under the covers will give you a better understanding, a better sense of some of the optimizations in the performance. So let's begin with service partitioning. You come into work one day and you find that, hey, you have a lot of email messages in your inbox, or perhaps you have a number of calls on your voicemail, depending on how you've actually set up your help desk system. And what you find is customers, your end users telling you that, hey, I submitted an approval request yesterday. I submitted an approval request 2 days ago, and I have not gotten the approval. Some of these approvals are time critical. That's because they are trying to access a resource, trying to access a file, trying to get into a share that they need to get information to. So what you realize is what happened actually was they went to the FIM portal site, and they picked a group that they wanted to join. The group has an approval workflow associated with it. So they click on it and they say, request to join. The workflow is triggered, and it is about to send a mail to the approver. However, it doesn't get through because the workflow is stuck. You might also hear from customers that are complaining that during certain peak hours of the day, they find that the portal is not responsive. Common tasks that they do at the portal are taking longer. When you look at that time, you see, oh my God, that's exactly the period of time that you're running your sync service at the back. Microsoft IT has an SLA with the end users that they tell them that we will make sure that any request or any approval that you submit or any updates that you make to the group flow to the system within 12 hours. So what they have to do is to make sure that the sync is running during the day, which is also the time during which most of the users are using the portal. So there is a recommendation there. We'll talk to you more about it when we get into the section. So as you look at the topics that you hear from your customers, you realize that administrators, when they're trying to administer the groups, there's a slow time, and that again correlates with the time you're running the sync engine. Now you go under the covers and you say, what's actually happening here? Why is it that it's taking so long? Why is it that the portal is not responsive? And you see, oh my God, there are 1,000 active workflows. When you see that large number of workflows in your system, it should trigger a flag in your mind that says, what is happening? Why is it that these workflows are all queued up and not executing? So you might want to look at service partitioning. So before we get into that, let's look under the covers of what actually happens with workflows. So workflows are executed by workflow host within the FIM service. When a workflow comes in, the FIM service executes it, creates it, and then submits it to the FIM service database. Now, as a workflow is executing in the database, the FIM service on the front end, what it's doing is actually polling the database saying, are you done? Are you done? Are you done? And that's how it keeps making sure that it can pick up the workflow as soon as the FIM service database is done with it and executed. Now, the nice part of this system is that you can bring into play another FIM service. And that FIM service, as soon as you bring it to play, starts polling the database again. So now you have two FIM services that are now load balancing the workflows that are in the database. You might want to increase the number of services within the partition depending on the need, and that's what we are here to talk about. The way you do that is you take a number of FIM services and group them in what we call service partitions. And each of the partitions are supposed to meet the needs of a particular workload. It may be that you want your user portal to be more responsive. You do not want to be affected by the sync service that you're running behind. And this is what we recommended to MSIT was, hey, you know what? Because you have the SLA of synchronizing updates to the system within the 12 hours, and you are forced to run the sync engine during peak work hours, make sure you take your sync workload and put it in a separate partition and leave the user partition alone. So coming back, so what ends up happening is that they created two partitions. One was for the user, and one was for the sync service. The key piece to note is that once you have created the service partition, the requests that are submitted to that partition have an affinity to the partition.
Right.
In fact, the request that is submitted to the partition includes the name of the partition in the request itself.
Now, can you move a FIM service from one service partition to another?
You can.
But you have to restart it, right?
Pardon me?
You have to restart it.
You have to restart it, and you have to make sure that you name it differently from the existing machines in the FIM service portal.
Good point.
And it's interesting that sometimes you might realize that there are certain workloads that certain periods of the year are more busy and you want to bring in more machines. That's where it becomes really important to do that.
Yeah.
So let's take a closer look at how workflow works. So when a user comes in to the portal, they make a request. And the request that we are talking about is an approval request, because I think that's what we are going to work through in a number of examples through this deck. And the request triggers an authorization workflow. The workflow is sent to the database. Now, the person who is supposed to approve the request is not there. Maybe he's gone for lunch. Maybe he's away on vacation. And the workflow has to wait for the person to come back, approve the request, and that's when the workflow will get rehydrated and execute. Notice that while it's waiting for the approval, the name of the service changes from service to none. That means it's waiting. It's not stuck. It is just dehydrating, waiting for an approval or an external event to happen for it to rehydrate. Now the person comes back, who's the approver, and after lunch, and they approve the request. Now, while they are approving the request, what's happening is the FIM portal is busy. The service may be actually the FIM service too. It might be actually servicing another request from the customer. And then what happens in the background is that once the user has approved the workflow, the name of the service changes to service 3, and the next service, which is in the partition, can pick up the workflow and continue working with it.
Right. So this is important if you're thinking about the relationship between authorization and action workflows, is that the action workflows might not be running on the same FIM service as the FIM service where, say, the request came in or the authorization workflows are run.
So, and the workflow, as you were saying, have an affinity not only to the machine, to the partition, they also have an affinity to the machine. So a single workflow can only be executed by a single service machine. In fact, what the FIM service workflow host does is that when it's picking up the workflow for processing, it locks the workflow with the FIM service names. This ensures that two FIM services are not simultaneously executing the workflow at the same time.
The workflow instance. They can both do authorizations, but only one particular authorization workflow instance can run on any one FIM service at a time.
And across different partitions.
Right.
So now we've told you what the FIM service partitioning is and how it works under the covers. So let's go back and look at some of the symptoms we discussed earlier. One of the symptoms we discussed was the fact that you might realize that the service portal is not being responsive at the same time that the sync engine is running behind the scenes. That may be the case, that may not be the case. What you should do is analyze the workflow load. Unfortunately, there is no single formula that we can give to you here that you can actually plug in numbers that will give you a yes and no answer. It's a very subjective decision. And it's subjective because you have different machines in your system. You have different topologies in your system. You have different requirements that you need to deliver to. For instance, one of our customers notices that there are a larger number of password resets on Monday mornings. In fact, majority of the resets that happen in the system happen on Monday. So what they have done is that they've created a separate service instance of password reset. And that means that they isolate the workload on Monday morning, and so the portal is still responsive during the time when most of the employees or some substantial number of employees are trying to reset the password. So coming back, so what you need to do is when you are looking at the workload, you need to observe a couple of things. You need to look at the portal response time. And how do you actually look at the portal response time, Mark?
Yeah, so one of the things we're going to be showing later is using the SQL profiler on the underlying database itself. Now that's kind of the low-level approach. Other things you could do is you could look at the WCF traces that the FIM service itself generates, or you could just look at the IIS log of the FIM portal instances. You go into go on the FIM portal machine, bring up IIS Manager, go to the SharePoint site, and you switch on the W3C logging. You can look at the specific amount of time each of the JavaScript calls that a user is making at the portal will take. You can see, for example, how long each search operation takes. And what we're going to be showing in just a few slides is how you can then trace that all the way from the FIM portal through the FIM service all the way down to the database.
So actually what I like is the more hardcore way of doing it is actually sitting in front of the portal and actually using a stopwatch, submitting a query or performing an action and seeing how long it took. That's how most customers end users will call you up and say, it's taking longer. You ask him how? Oh, I actually looked at my stopwatch, or I looked at my watch, it's taking a couple of seconds longer. So that's another very brute force way of actually seeing how responsive your portal is. So what you do is after you've noticed that there is a correlation between a certain workload and the portal responsiveness, you want to look at the active number of workflow instances. Then what you do is after you've looked at the active number of workflow instances, you want to see where the workflow is being generated. So the way to look at active workflow instances is go into the administration portal, click on all resources, click on workflow instances, and do a search. This will give you an instance of all workflows in the system. It will not isolate the active workflows. So what you need to do is actually create a filter on active workflows. And the way you do that is you look at the status. You say, is the status completed? Or is the status terminated? The difference between the two is terminated means that the workflow was shut down before it had completed or executed on its task. This will give you a total number of active workflows. And the workflow count is at the bottom is about, we'll show you the total. Here it's an elevated count. This is the actual total number of workflow instances that were in the MSIT system. This is not the count of active workflows within the system.
Right, because the workflow instances that you'll see here on this list are not necessarily all running at the time. They could be dehydrated. They could be authorization workflows that are waiting for an approval to come in. Now, one way of looking at this is through the portal. Another way you could get this data would be to use a PowerShell script. You can do a single line of PowerShell where you call the FIM export fimconfig command, and you pass it the same XPath expression that the portal generates. So if you go into the portal and you do this query against the FIM service, look at the WCF trace log of the FIM service, and you'll see the XPath expression. You can then take that expression and provide that as an argument to export fimconfig. Count the number of resulting objects that come back from export fimconfig, and you'll know the number of active workflow instances in your system. You can just run that as a batch command in PowerShell every few minutes, and if you see the trend over time going up, then you're going to know that there might be some problem. Perhaps the machine has failed, and that's causing the workflow instances to back up. Arshad is going to tell us about what we're going to do to recover from that.
So after you've done the analysis, what is it that you do with the data? Our recommendation, and it has been to our MSIT internal deployment, is that you should separate workloads. You should find the workloads that are actually impacting the portal and try to isolate it. The reason why you want to concentrate on the portal is because that's where majority of your end users are going to be. That's where they're actually going to see the effect of this partitioning, whether it's the administrator trying to administer the group, or it's the end user just trying to join or leave a group. So what we suggest is that you create two partitions at least, one for user services and one for administrative updates and for sync services. The piece you do want to note is that you want to adjust the timeouts for the administrative partitions. That's because what happens is that the administrative workflows, the sync workflows, typically take a lot longer to execute than a typical user workflow. And there are a number of other dials that you have that you can actually set. This is the web services and the SQL. Do you want to tell us a little bit more, Mark?
Yeah, you probably want to take a look first at your Microsoft.resourcemanagement.exe.config file. We have documentation on this config file on MSDN that walks through all the different settings you can configure around timeouts. So what you can configure for your FIM service instance is how long does the FIM service allow each incoming request to take. You can also configure what timeout indication that the FIM service provides to SQL. So what you can do is you can set this differently for each of the FIM service instances in each service partition. If you want to, for example, allow an administrator to have a longer timeout period, you don't want to have a administrator trying to enumerate all objects, enumerate all set members, enumerate all requests and have that timeout. But you might want to have a shorter timeout period for the portal.
So now we've talked to you about one of the symptoms that we started this segment by, which is about how do you actually manage the workload, how do you actually manage the response. What remains is the stuck workflows that we talked about. So it's important that when there is a stuck workflow, you look at the service machine name. So here, what happens is the user submits a request, and we've seen this before in the previous slide. It kicks off a workflow. The workflow is submitted to the database. Note, this is an active workflow. This is not a workflow that has been dehydrated. How do you tell? You look at the owner name. You notice that the owner name is service 2. It is being actively processed. And what happens is one of your machines decides to go. Poof. Never happens, but suppose it happens. Suppose one of your machine fails. And then what do? You notice that the action workflow is stuck. It's not moving forward because it's completed the database query that it needs to do, but it cannot go back to the FIM service. So you can do one of two things. You can actually introduce another FIM service machine in that partition with the same name, or in this example, what we've done is we've taken FIM service 3 and we've renamed to FIM service 2. What this does is that it can then resume the workflow that was stuck. As we had mentioned earlier in this section, is that the workflows are very closely associated, one, with the partition, two, with the service machines. And in this case, it shows you that there is an affinity between the machine name and the workflow.
Right.
And that's how you unstuck workflows. So let's do a how-to. Now, how do you actually set partitions? There is a file called Microsoft.resourcemanagementservice.exe.config. This file, with its unique name, can be found if you just do a search in your Windows system.
Yeah, it's in program files.
It's in program files.
Yep.
Or it's at the same location that FIM is installed.
Yep.
And under that config file, there's an XML resource called Resource Management Service, and there you can actually see both the service partition name and the service name.
Right. We've documented all of these XML attributes on MSDN, so we'll have more information on which ones you can set, which ones you should only set if CSS asks you to, and which ones you should never set.
Great. And as we mentioned, one of the things that you should note is if you do not set the partition name defaults to the host name that you initially set the FIM services. So now we've actually come to the segment of what are workflows, how do they execute in a service partition. Mm-hmm. The next thing what Mark is going to do is going to take us and peel the onion back and talk about a little bit more about workflows and workflow hosts.
Yep. So now we've seen the relationship between the workflows and the FIM services. If you have multiple FIM service instances, we've walked through very briefly how does each workflow know what FIM service to run at. Now the next question is, what's going to be happening within a FIM service instance? Sometimes we'll see behavior where we're looking at CPU utilization of FIM service, particularly after a big sync operation, after you've done a large import. And we see that there is a high CPU utilization on the FIM service itself. So probably that's due to workflows. If we saw a big utilization on SQL, it's a database operation. When we see this, we need to think, how do we know that we're running the right workflows, and how do we make sure that if we have multiple workflows that they're going to be scheduled to the appropriate FIM service machines. First, let me talk a little bit about how workflows run through the FIM service. A request comes in to FIM service. We have a component called Resource Management Service. That's our WCF endpoint. And that brings in, today in FIM 2010, requests from either WS Transfer, WS Enumeration, the web service protocols, or from Exchange, if a user submits a join group request. Regardless of how the request gets into FIM, the Resource Management Service will construct an internal message and hand it to the request dispatcher. Now, the request dispatcher is responsible for talking to the FIM service database and evaluating the MPRs, the management policy rules, that are relevant to this request. So if the request comes in from the portal or comes in from Exchange, independent of how it arrives, and it's a join group request, the request dispatcher will look at the target object, the group, look at the requester, it'll look at the MPRs. It'll find that there is an MPR for requiring the group owner to approve. What the request dispatcher will do then is assemble all the management policy rules, all the workflows that are needed to be run for this request. Now, once it has that, it's going to hand it over to a component within FIM called the host activator. The host activator is responsible for scheduling and managing each of the workflow hosts. Now, within FIM, we have multiple workflow service hosts. We have two on the left that are shared. We have a shared workflow service host for all the authentication workflows, for all the password resets that are coming in, and we have to authenticate the user. We have one workflow host for that. We also have a shared workflow host for all the action workflows, all the typical approval authorization workflows, except for the approval activity. And I'll talk about why approval activity is different. Within the host activator, we look at the workflow definitions. And if the workflow definitions include any activities that are based on the receive activity is an element of Workflow Foundation that says any workflow activity that makes reference to a WCF endpoint, where it's going to be asynchronously waiting for messages, waiting for requests coming in, we're going to schedule those separately. We're going to put each workflow definition that has a receive activity in its own workflow service host. Now, the approval activity within FIM is a subclass of receive activity, which means that every workflow definition that has an approval activity or custom activity that has a receive activity that you write yourselves is going to be scheduled into its own workflow service host.
So does that mean, Mark, that if I have multiple instances of a workflow definition that requires approval, we are going to create a new host each time for each instance?
We'll only have one host for the workflow definition, but within the definition, we might have multiple threads. I'm going to talk next now about what's going on within a specific workflow service host. So this is just a very high level. Request dispatcher gets the request, determines what workflows are needed, and then hands the request to host activator, which then will schedule the workflow host where that workflow definition is going to run. If it's just an action workflow with no receive activity, let's say it's notification, it'll go down to the shared workflow host. If it's an approval activity, it'll find the workflow service host where that workflow definition is and schedule it there. Now, if we rotate the picture somewhat so we can focus now on what's going on within the workflow host, we'll see in the upper left what happens when there's a create or a start workflow activity. So start workflow activity would occur when we are going to be having an incoming request come in, like that join group request. Within the workflow host, there's a scheduler. The scheduler is responsible for doing one of two things, for loading and creating instances and for scheduling them into a .NET thread pool. Now, if we look at the workflow instance scheduler, we're going to see that it has a queue, and it's going to be working with the .NET thread pool in order to assign each of the workflow instances that are required for that workflow definition to one of the .NET threads so that they can run. When a .NET thread is available, the workflow instance runtime will start up, take that activity, take that workflow definition, and start running it on the queue. If it's, say, an approval activity, and the approval activity sends out the request to the group owner or the manager, and then it waits. After a few seconds, the workflow instance runtime will determine that that workflow is not going to return right away, and it can be persisted off to disk. The workflow instance runtime will then hand it back to the workflow host and go into instance unload. Instance unload will now persist the workflow. Along the right-hand side, we're going to see that there's 4 elements to where workflows live within the FIM service database. The instance state is the data that Workflow Foundation itself manages around the workflow. When you tell a workflow instance, persist yourself, it'll serialize itself into effectively a byte array, and the FIM service instance will put it up into the instance state. That's opaque to the FIM service. The FIM service doesn't know what's going on in there. That's managed entirely by Workflow Foundation. The workflow definition and workflow instance objects are visible to the FIM system. Another component that's going on within FIM, if you look at the flow along the bottom, is what happens when the workflow host determines that it's idle, that there's plenty of available threads in the .NET thread pool for the workflow instance scheduler. What it'll then do is it'll then pull the list of workflow active instances along the right-hand side, and it'll see if there are any workflow instances that are runnable for this service partition that aren't assigned to any other FIM service. If it finds one, it'll lock that workflow. It'll go right to the database and say, this workflow is now assigned to this FIM service. It'll take it, bring it up to the workflow instance scheduler, assign it to a thread, and that workflow will start running. Now, as Arshad was talking about earlier, if we have a failure at that point, if this whole system goes down, the workflow instance is still written in the database as being assigned to, let's say, FIM service 2, whichever FIM service this happens to be. So that's why it's important that if you do have a system failure, to ensure that you have a way of recovering from that, you can reassign another FIM service to have that system if it's not going to be coming back anytime soon. Otherwise, those workflow instances will stay blocked. Once the workflow completes, let's say you get the approval coming in, or let's say that no approval comes in and it times out, then the workflow instance running will complete. It'll unload, it'll clear its state out of the instance state database if it had any, and it'll go back to the workflow instance scheduler saying, I'm completely done. That thread is now available for another thread to come in for another workflow instance. Now this is very complicated, but the key thing to take away from this is to go back to the previous slide and think about the relationship between the different workflow hosts. Because what's going to happen is all of these workflow hosts are going to be competing for the same .NET thread pool. Within any .NET application, there's only a single thread pool. So what you're going to have is a possibility for contention between all the workflow service definitions along the right-hand side, all those workflow service hosts, if you have a very large number of approval activities in different workflow definitions. So our recommendation for this is when you're thinking about designing your policy and you say, we need to have approvals for this, it's important to keep in mind, if you're going to have a very large number of approvals, potentially multiple approvals for a single request, think about how you structure it. If you have separate workflow definitions and each workflow definition separately has to get involved with running approval. So let's say you have workflow definition 1 gets the user's manager to approve. Workflow definition 2 gets the group owner to approve. Each workflow definition has a single approval activity, meaning they're going to be scheduled separately from each other. Alternatively, you could have a single workflow definition that has 2 approval activities, one to get the user's manager to approve, the other to get the group owner to approve. It might achieve the same effect. It might be appropriate to your environment, but it's going to be scheduled as a single workflow definition, which means it's going to stay within a single workflow host. It won't get rescheduled out to another system because it's a different workflow definition. If you're writing your own custom workflows, if you're writing your own custom activities, keep in mind what's going to happen if you use the receive activity. You can. I mean, you can use the receive activity if you want. If you want to have FIM service calling out through some other protocol to different databases, if you want to go and have an action workflow talk to another system, you can use the receive activity. All that'll mean is your workflow definitions will now get scheduled separately from those of the rest of the FIM service. Now that was very briefly how we think about workflows and the relationship between workflows and FIM services. Now I want to drop down another level and start talking about what's going on within the database itself around how we handle query operations. You know, we often hear at Microsoft from our own MSIT organization, people calling up saying, the portal's slow today, or I tried doing this really complex operation and it's slower than I think it should be. We also have seen situations where we'll go and be monitoring the SQL Server and say, the queries are just taking inordinately long today. What's going on behind the scenes? What's scheduling this?
So as you mentioned that when you look at this SQL Server and looking at these SQL Server loads, what you should understand is how actually this is being triggered. Mm-hmm. What you should see is that search is a fundamental part of the experience that you have when you come to the FIM portal. Any action that you do as a user, the first step that you do when you're looking at your own distribution group, or when you're looking at the security groups, you do a search. You look at your security groups or you look at your distribution groups.
Yep.
There is addition to that when you're an administrator, when you're looking at the sets, when you're looking at the MPRs, first thing that you do when you go into the vertical, you do a search. In addition to these implicit search, there is also the notion of explicit search. There are two ways. They're both related, but there are two ways that an end user can actually execute the search. First, the way that they execute the search is that they go into the search box that's on top of the FIM portal. And there, that search is executed against the search scope that you have written. This is where you have control over how efficient that search is going to be. I use the word search scope. What is a search scope? The search scope is essentially the universe of target objects over which you are going to conduct the search. You have the ability, and we're going to talk a little bit more about this during this talk, is how do you actually modify the search scope. The second part of the search that you can best do is to educate the user. Is that when they are trying to do a filter builder where they're actually constructing the search using number of attributes, you should educate them that the more complex the search that they are going to run, the slower the request is going to be. This is natural, this is normal. And coming back to what Mark mentioned earlier, was that as the volume of queries increases, there is an increased load on the SQL on the back end. How do you know that? Typically in organizations that we've spoken to, the SQL is owned by another department. And what they do is they call you up and they say, hey, the FIM service is consuming a lot of cycles on the SQL machine. Or if you have actually the SQL server under your control, there are a number of tools that you can use to actually see if the workload. Now what happens is here you have queries that are being generated as a part of user actions. Here you have queries that the user is executing against the FIM portal, and that is increasing the load on the SQL server. What ends up happening is because there's an increased load on SQL server, the overall performance of the FIM service may be slow. What the users might see that some of the actions that are performing on the site are slow because there's a SQL overload. So basically what you're doing is search is an important part, not only of how the responses and some of the search-related activities behave, it also impacts how the rest of the portal behaves. So let's take a look under the covers of how search actually works. What happens is when this user comes to the FIM portal site, they execute a search. And in this particular case, what they are looking for is a user by the name of Arshad. Happens to be me. It gets a nice way of getting my name on the screen, is that you talk about queries with your name in it. So he's doing a search with Arshad in the display name, and what the portal does, it takes the query and takes the string and converts it into an XPath. This is a pretty standard XPath. So it says, look at person objects, look at the attribute called display name, and see if it contains the name Arshad. So once the portal has taken the search string that the user has entered and converted into an XPath, it submits that XPath to the FIM service. Now what the FIM service does, it takes that XPath and parses it, translates that XPath into an object model, and from the object model, it generates an XQuery. So what happens is that the user types in the search string is converted into an XPath, the XPath is sent to the FIM server, the FIM service then converts the XPath into an object model and then converts it subsequently into the SQL query that is going to be executed to the SQL server. So let's look at the SQL query in a little greater detail. What you see is that there is an XPath that says, hey, display name contains Arshad for an object type called person. How does that translate into a SQL query? Essentially, ignoring the actual strings in the SQL because those are related to the table names and so on that we have within the FIM database. Essentially, what you're doing is let's look at a table that has all person objects. Then let's get the attribute called display name. And once you have the attribute called display name, let's look for Arshad. So this is essentially the SQL query that is generated based on the string that has been entered by the user on the portal. Now, we've told you this before, that FIM is very granular in the way it looks at writes. It looks at writes not only at an object level, it looks at writes at an attribute level. And you can see it more clearly than here. What ends up happening is you've got the 10 lines of query that have been derived from the original search string that the user entered. But in addition to that, what FIM does, it does a bunch of checks. What it does, it tests against the MPRs. It sees, do you, as a user who's conducting the search, have the right to look at that object? For instance, it might not make sense for end users to see request objects. So what you can do is make sure the MPRs are set so that the users cannot search requests. So here we are, it tests and says, hey, can a normal user look at the person object? The answer is yes. Once you get the answer back, it then goes to the next level. It says, hey, let me see if you have privileges to see the display name. And in this case, yes. You have access to the display name, and you can see if it contains Arshad. Now, of course, the person object, depending on how you've set up your FIM, might also have salaries and other PII associated. What you want to make sure is that there is nobody in the company that can just admit and search, show me the salary for Mark. Or Mark can show, hey, show me the salary for Arshad, because that is PII. And the way you set that is to make sure that there is a read MPR that prevents other people from looking at your salary.
Right. Now, the important thing to note here is that unlike other database-based applications, the MPR evaluation is actually going to occur on the SQL server itself, which means that the FIM service, as part of this SQL query, is going to send over references not only to the display name attribute that they're searching on, but also references to the MPR tables, so that the evaluation of can the user make this query will be performed on the SQL server rather than on the FIM service box itself. If you ever looked at the CPU performance of the FIM service, you'll see that it stays relatively low while there are queries going on. All the actual heavy lifting of evaluating the query is going on in SQL. And that allows SQL Server to optimize these queries.
So what ends up as, according to optimizations, is that the SQL query takes the XPath and generates a certain number of queries based on the original string that we showed you earlier in the slides. And then it does a number of additional
Rights checks.
Pardon me?
Rights checks.
Rights checks, that's right. So it does a bunch of rights checks on it. And as a proxy of complexity of the query, we are just using the number of lines in the SQL query. That's not the right proxy to actually, if you're doing a detailed analysis, it's just a quick back of the envelope calculation. So what you notice is that if you have a single attribute, there are a certain number of queries that are generated. As you increase the number of attributes, the complexity of the query increases, also the size of the query size increases. Now, the complexity and the size of the query does not necessarily mean that it's going to take longer to execute that query. That execution time is based on some of the query optimizations that you do within SQL. The point here is, hey, what is it that you can do to actually make sure that you're reducing the complexity and the load of SQL that you are noticing on the back end? So as we talked about, the first thing you can have control directly over is the search scope. The search scope, coming back again, is the default search target area that you are determining for a user when they execute a default search. So what you look at the search scope is you look at the number of resources within the scope. Now clearly, if you are trying to do a star search, you are going to run into thousands and thousands of objects for each search. That's not a sensible thing to do. So what you want to do is, depending on where the user is, depending on where the administrator is, you want to filter that. And I'm going to show you in a couple of minutes where do you specify the number of resources within the search scope. You also want to look at the number of attributes that you're searching on. Yeah. Like in the previous slide that we showed you, as you increase the number of attributes, the complexity and the size of the query increases relatively. So what you want to do is to make sure that you've rationalized the number of attributes that you're searching on. And of course, last but not the least, is the type of attribute that you are searching on. Is that if you are searching on an attribute that is a text string, it's going to take longer than if you were going to search an identity field. So object types typically are easier to search because object types translate into an ID in the system behind, and then you can do a quick comparison. So what you want to do when you want to tune search scopes is look at the number of attributes. You want to look at what you're searching over and where the default scope is showing up. So on the right-hand side, what I am showing you is a couple of important pieces of search scopes. How many people here have actually created a search scope? Could I show of hands? One. Widely used feature. Maybe you should look at it more carefully the next time. Take a look and how it actually impacts and why is it important for the FIM portal. So what I'm showing you here are 2 or 3 steps in the process. First, on the left-hand side is called the usage keyword. There are a number of predetermined keywords that FIM has that shows you where the search scope shows up. So if you have username or basic UI, that means it's going to show you across all pages. Or you might want to create a certain policy-restricted search scope. You create your own search scope name, and then you define a policy, and that determines who, where, and when does it show up. The next piece that's also important that we've talked about is the attribute search. This is where you actually specify the attributes that you are going to be searching on. In this particular case, we are searching on display name. The next down is the search scope filter. This is exactly the XPath that determines over what search scopes we are going to run over. What is the target universe of objects that you're going to search? And in the next couple of minutes, what we are going to show you, when we show you the SQL Profiler demo, Mark is going to show you the XPath that's generated as a result of these queries.
Right. So you could put in /star there for the search scope filter if you're doing your own custom search scope, but you probably don't want to, especially if you're going to be allowing your users to search the display name attribute. And the reason for that is if you're searching on display name across all objects, you're not only going to find the object you want, like a person named Arshad, you're also going to find all the requests that relate to that object. So a request to create a person named Arshad, an update to the person named Arshad, and so on. That might be a value to the administrator, but probably that's not going to be a value to the end user. The end user just wants to see a person or a group. They don't want to see a gate registration or workflow or other objects. Even if we're filtering that out in terms of objects that we want to return to the user, it's still just going to create additional complexity and create more work for the SQL server.
So as we talk about always is the MSIT piece. And the factoids are basically, we have Jeff Stamen here who has been working with MSIT for a long period of time, and then I took it over from him, and we can share with you some of the experiences we've had while talking to MSIT, while making some of the optimizations. And one of the optimizations we've talked about is a very frequently used query that is executed by Microsoft employees is looking at their own security groups. So in this case, what MSIT did was essentially created a search scope that's very particular to that. And you notice most of the attributes that they use, in fact, all of the attributes that they use here in the search scope are not text-based. Mm-hmm. So the first one is about, hey, the security group is of type security, and this mail-enabled. Mail-enabled means that most of the security groups are mail-enabled so that there is a mail that is sent out and it's a DL that the mail is sent out to. There are some of the security groups that are not mail-enabled. And then the last one that you notice is AG managed. That is an internal flag that we use to determine some attributes that we have created within MSIT.
Yep.
It is also an indicator that some of these groups are managed by some of the older tools that we have within MSIT. The next one that we have is distribution group. Look, it's a very simple search scope. It says the type is definition, and again, the AG managed is false. So these are 2 examples of search scopes that MSIT has developed to help improve the performance of search. So now we've talked about search scopes. That is how you actually fine-tune the searches that are being executed. The larger task, the harder task, the more intriguing task is actually identifying which queries are slow. Because remember, there are 2 ways that the user can run a query. One is through the default search box, which is through the search scope that you've defined, and 2 is through the filter builder. And in the filter builder, there is limited control that you have. What you can do is notice that some of the queries that the end user is running in the filter builder may be text searches. And how do you tell if an attribute is a text search? Simple, look at the filter builder. They have a field that says contains with, starts with. That's an easy indicator sort of showing that this is a string. The more complex way of doing this is that you might actually look at the schema definition for that object and see what is the string, what is the type of the attribute that you're searching on. And as I had said earlier, if you're looking at or doing a search over an object type, it is an easy search because the object type is represented by a GUID, and that's an identity search. The other piece you want to note is that people think that if they have SharePoint indexing on, somehow the query is going to be quicker.
Well, yeah, it's on by default. So the key thing we recommend is make sure when you install the FIM portal on a SharePoint site, either WSS3 or with FIM 2010 R2, will also allow SharePoint Foundation 2010 or SharePoint 2010 to turn off SharePoint indexing. SharePoint indexing is basically a crawler, and it'll start crawling through the FIM portal, and that's just going to create unnecessary load. SharePoint Indexer can't really do anything with the results because it doesn't have access control. SharePoint Indexer doesn't have read access to any data, but it's just going to keep creating load on the FIM service by attempting to walk every page of the portal, including all the searches, all the update operation screens, until it finds something. So turning that off can help to cut down on queries that are hitting the FIM service, hitting the database that don't give any value.
So the intriguing part of this analysis is to use SQL Profiler.
Right.
And Mark, do you want to start
let's take a look at
setting
that.
up the demo? And what the SQL Profiler does is a lot of powerful things. And as I said earlier, that you may not have access to the SQL Profiler, because typically in large corporations, SQL is managed by a separate division. But you can always ask for permissions to look at the SQL Profiler and start executing it.
Yeah,
so Mark,
you can certainly run it on your own system if you have a test FIM instance. So here what I've got on this box is FIM 2010 R2 currently under development. And I happen to have basically an all-in-one configuration where I've got SQL Server installed locally as well. I only have a handful of users. What I'm going to do is I'm going to bring up SQL Server Profiler. Now, how many of you use SQL Profiler already? A few of you? Yeah.
All right.
So that's good. We can actually point this profiler at the database where FIM is installed. So I start a new trace, happens to be installed on local because I'm just doing a test. Now it's important to go over here to event selection. By default, the profiler is not going to capture events that are of interest. It's not going to capture the right data. In particular, we're not interested in audit events. We're not watching who's logging in and out of the FIM database. We're not interested in looking at T-SQL batch operations. We're not even looking at our existing connections.
Mark, don't forget to click on the text data for the RPC file, because that's not checked on by default.
Yeah, you do want to turn on the text data column for RPC, because what that's going to do is that's going to save all the queries that are coming in to SQL. We're going to look at that. So now we've selected all the parameters around RPC operations coming in to the SQL database underlying the FIM service. I'm going to start this query running. Now we see going on over here, there's actually, I'm not doing anything on this box, but there's all these queries. That's the FIM service polling, looking for active workflows. It keeps polling every few seconds to see, are there any workflows available? Because it's idle. It's desperately looking for work. It's thinking that there might be some workflows out there. I'll give it something to do. I'm going to go here to the FIM portal, go over to the Users tab, and just do a search. Or I'm going to search for a particular user. Let's say I'm going to look for Chad. So I look for Chad. I've got Chad in my database. Great. Now I'm going to stop my SQL Profiler trace. Bring that up. So what I can see now is if I look back over the trace, I can see all the operations that were occurring at the FIM service database level during the last few minutes. You can see that a number of these are coming in from the FIM service itself, but you also have a few queries like this one here that are coming in with a username that's not the FIM service. That's actually me at the portal. And we can see for each one what SQL is doing behind the scenes. How many reads, how many writes, how long did this operation take?
In this example, we have a limited number of people in the database. So when you look at the query execution time and increase the number of attributes, it doesn't make sense. We cannot really demonstrate to you the delay that happens or the execution increase in time as you increase the complexity of the query. However, if you do have a live system on the back end and you run the SQL Profiler, you will notice a number of these things more distinctly than we are able to demonstrate at this demo.
Right. So we see here that this is the query that I made looking for the user Chad. We can see, it didn't take very long, only about 8 milliseconds, because the entire database was so small it was in memory. But what's new that we've adding in an update to FIM is if we look here within this massive SQL expression, at the very end, we're going to put in the XPath that the FIM service is evaluating. This is going to allow you to correlate the operations that are going on within the FIM service database with requests that are hitting FIM from the portal from the end users. So what you can do is you can have a SQL Server profiler running on, say, your test or staging FIM service database. You can leave it running. You can set flags that say only interested if duration is greater than 1,000, or only interested in operations that are not coming from the FIM service itself, that are coming on behalf of a particular user. And then for those requests, you'll be able to see with FIM 2010 R2 down here at the very end of the query, the XPath expression. Here we can see that because I used the default built-in search scope, when I searched for the user Chad, it was doing a starts with query for one attribute, a contains query for another attribute, all ORed with a starts with query for the account name attribute. So if I find in my environment that that query is taking an inordinately long time, if I've got a million user data set and the durations are worse, maybe I need to add more memory, maybe I'm running on a shared SQL Server box with other applications within my organization, then they say, reduce your load on SQL. I can configure my search scope. I can change so that I'm using, for example, a starts with rather than contains within the default search scope for users. And that's going to then affect, you can then rerun this query, watch it with SQL Server Profiler, and see the impact of changing the XPath in terms of the I/O operation that SQL is performing, in terms of the duration of the query itself.
So Mark, do you actually want to scroll up on this query and show them the writes pieces and the...
Yeah, because down here at the very end, we're going to see the XPath expression. We put it in there to allow you to find it in
And this XPath expression, if you go right up to the top of the query, is actually translated into a SQL query that I showed you up on the slide. And right here.
We see right here, here is the elements of the query where we put in actually little comments within SQL to help you find your way around it, because it is fairly large. So here we're seeing elements of the SQL expression, the person object type, the male nickname. Here we're using the like operation in order to do that query.
And if you scroll down, further down, here is where we notice that we have a number of queries that are being created to do the writes check. Remember we talked about FIM doing a writes check at a very granular level. Here example is the query that you ran in the SQL profiler. You can actually go ahead and see the writes queries that we are executing against the database.
So here you can see the elements of the query that are referencing our internal MPR tables that are needed to show that the user has read access, that the policy is in place. Further on down here in the query, I'm not going to go through it in gory detail, but you can take a look with the profiler and you can see what's going on to not only do the MPR evaluation for what attributes the user is allowed to search on, but also what attributes of the target object, Chad himself in the database, what attributes is the portal looking for, and to ensure that the user does have read access to all those attributes. All that evaluation is going on here within the XPath expression is translated into SQL.
Great. It's a great demo. Thanks, Mark.
Yeah, so now let's switch back to our presentation.
So what we just talked about is at the top we started with the conversation around workflow hosts that were in the FIM service. We then looked at the interaction between the FIM service and the FIM database in the context of the search and the search scope. Now, as we are going to further down the FIM stack, and we are going to look at the database and talk about system objects.
Right, because we've been looking at query performance. Now let's look at update operations. So what do we see that are triggers for needs for optimization? Well, growth of your SQL database in log file, that should be the number one sign. You're watching your disk utilization of FIM over time as you've been rolling out your deployment, and you see that it's going up over time. You think, how is this log being used? How is the SQL database being used? What's in these tables that FIM is maintaining? Another trigger might be that you're seeing timeouts, not only of search operations, but update operations. These can be particularly worrisome when we do have a FIM update operation timeout.
So the key piece to notice is that we talked about search timeouts, search taking long. There is not necessarily a single cause for those. There are a number of causes. And what we are doing here is showing you how to actually debug some of the causes. We look at the search context, and now we're going to look at the system objects that are created.
Right. We're also at the end going to talk a little bit about the FIM-MA, and in particular the work we're doing around the FIM-MA and its interaction with the FIM service. But first let's look at what's going on behind the scenes. We've got a table that represents each of the objects within the FIM database. And the reason we have this table is you can do queries with XPath like /star, get me all objects. So FIM has to be able to evaluate that. What this means, however, is that this single table of all the FIM resources includes not just the people and the groups and so on, or the MPRs, but also all the system objects. Every time you go to FIM and make a request, we create a request object. Every time a workflow is started, we create a workflow instance object. These are real actual FIM objects in the database. They have attributes, they act in just the same way as a person or a group. We don't have virtual objects that appear to be in the database. They are actually real. You can do queries, searches, delete these objects if you wish to, and so on. They're all stored in exactly the same way as every other object, like a person or a group. So what this means is when the user makes that request to join a group, you have a WS transfer update operation that comes in for the group itself from the user. What can go on behind the scenes is we'll create a request object in the database. We'll persist the request. We'll run the MPR evaluation on that request, but in the request dispatcher and see we're going to need workflows. We'll create workflow instances. A new workflow instance object will be created. So now we're up to 2 objects. We're then going to have that workflow instance start. That workflow instance will say, there's an approval activity. That approval activity needs to have an approval. We'll create an approval object. Now we're up to 3 objects in the database. That approval is going to wait there for the administrator to come in. The administrator or the group owner or someone's going to come in and approve that request. That's a request. So that's a request object. We're going to go and record that into the database. We're going to create an approval response object to say, who was the user who approved it? When did they approve it? And so on. That's an object. We're going to have a compensating object or a correlated object that updates the approval. So we're going to keep updating the state of the request. We're going to keep updating the state of the workflow. Each one of these is going to cause more and more rows to go into the different tables. Probably you're going to have about 140, we just did a measurement a few minutes ago, of different row updates that are occurring within the FIM service database for a single join group request. And the reason for that is all of these objects, the requests, the workflow instances, the approvals, the approval responses are actual real FIM objects, just the same as the group. So what's this mean?
So as we notice that each request that is coming into the FIM service is generating a number of system objects.
Yeah.
And what happens is that everything in FIM is a request. And what we are going to show you here is the number of sources of requests within the FIM service. We'll start on the left, which is the clients. What are some of the external triggers that actually start requests? We start with the common one, which is config migration and config upgrade. What is this? When you have FIM in staging and you want to change a configuration, what you do is you run PowerShell scripts. Those PowerShell scripts are actually calling in the back end to FIM web services, and they're starting to trigger a number of requests. Mm-hmm. And you should be mindful, depending on when and where you actually do the configuration, because it's going to have an impact on your portal. That's a good segue. You also have the portal, where users are interacting and conducting a number of activities. All activities that have create, update, or delete are going to translate into a deeper request within the FIM service.
Mm-hmm. Well, password reset.
And additionally, so we've talked about the portal. What we haven't talked about is the password reset. We did have an interesting talk yesterday on password reset, where we discussed what we are doing for password reset and what we are going to do in R2. Essentially, in password reset, there are 2 main activities. One is that the user registers for password reset. They might want to provide the data for the gate. Out of the box, FIM ships the Q&A gate, and the user, when they are registering for password reset, are going to answer. When they when they register for password reset, that's a request, and it triggers a number of auth-n and auth-z workflows on the back end.
Right. So it creates, when you do that registration, the request object for the user registering, as well as the workflows for the workflows running during registration, and a gate registration object that records the user's answers.
So once you have the users registered, of course, then they have to start resetting it. And in the morning, like we've talked about, on Mondays, typically there's a heavy load on password resets. At Microsoft, we have a number of teams that have actually created custom applications. These custom applications are calling into the web service, into the FIM web service, so that they can interact with the FIM service. The reason why some of these groups have actually created a custom object is a custom application, The reason why they've created a custom application is that they want a little more bit of control over how people are added to groups. The example we have is of the Windows test team. The Windows test team runs a number of tests on different pools of machines. And during the day, what they do is they take a tester and they add him to a certain group. For 3 hours, he runs the test, and then they take him out of the group. They want to make sure that there is control over who is running what tests in a certain set of pools, and the way they do it is through groups. And for this, they've actually created a custom application. Now, there are other number of different types of custom applications that you might have within your corporation. Each of those applications, when they are calling into the web service, they are generating a request on the back end. So there is a load that is being generated by custom applications when they're working in conjunction with Portal, the password reset, and other updates that you're doing to the system. The synchronization service, I'm going to touch this a couple of minutes, so let's leave that alone. The other big client that we have is Outlook. Outlook 2010 has an add-in. And what that add-in does, it allows people from within Outlook to add themselves to groups, remove themselves from groups, join groups, leave groups, add members to groups, remove members to the groups. What that does in Outlook is that it actually sends an Exchange message to Exchange in email form. What Exchange does is sends a notification to the Exchange mail listener in the FIM service. And each of those updates that you do, add a group, add to a group, remove a group, add a member, remove a member, is generating a request on the back end.
Right. So internally, we translate those requests coming from Exchange to exactly the same data structure as if a request came in from the portal. We use basically the same model as WS Transfer that the portal or custom client would use.
So now that we are in the guts of FIM, let's look at some of the other events that are happening when FIM. What are some of the other activities within FIM that generate requests? The common one is what we call collateral workflow. What is a collateral workflow? Collateral workflow is a fancy name for workflows that are triggered as a result of other user actions. So let's take a very specific example. So you have created a policy that runs provision AD users synchronization rule for all full-time employees in your company. So what you do is you create that action workflow and you click the run on policy flag. Now when you go ahead and create the MPR and you add the action workflow and finish creating the MPR, the workflow is going to be run on each individual user and provisions the user to the AD.
Right. So all those are going to be run under the system event context. So you can see when you look at the FIM portal, after you add an MPR that references that, a large number of workflows run, one workflow running for every user in the target set that's going to go and, in this case, do the user provisioning.
So the first one, the original request is creating the MPR, and the collateral workflows are the ones that are running and provisioning the AD users. We've talked a lot about workflow hosts, so I'm not going to spend a lot of time on this, but essentially a number of workflows themselves, when they're being created, when they're going to be resurrected, when they're going to be removed, are also generating a number of requests.
Do you have any requests coming from SQL?
Yes, we do. Good segue. So what it does is that we have a number of system jobs that we have scheduled on SQL Server. One of them is what we call temporal events or timed events. Let me give you an example. At MSIT, what we have is groups that have a life cycle. We make sure that a group lives only for 6 months, and after 6 months, the user has to go and extend the life of the group. This makes sure that we do not have a large number of extinct groups that no longer nobody is using, but they're still in the system. So the way that we do that is through group lifecycle management. And we have a temporal event. And what that does, it does and checks which are the groups that are going to expire within the next 60 days. It takes those groups and sends an email to the owners of the group saying, your group is going to be expire, please attribute it. Extend the life of the group. So as you come closer and closer to the date of expiry, more and more emails are sent. And the way the email is sent is through temporal events, because SQL says, which are some of these other timed events that you have in your system, let me run those workflows. That's an example of a temporal workflow. The other thing that also runs is from SQL is set corrections. You have, during the day or during a specific period of time, you have a number of updates to the set. What FIM does at the end is to actually do a sanity check and sees, are all the members in the right sets? And when it does the set correction, it also, when it fixes a set, it also triggers the set transitions MPR. So in itself, when you're running a number of set corrections, you are generating a whole new set of requests. Finally, what I left out when we started out this conversation is the synchronization service. So the synchronization service is part of FIM, but it is external to FIM service itself. And the way it interacts is when you have a FIM MA, and when you're running an export, it is actually triggering a number of MPRs. You want to tell us a little bit more about that?
Yeah, well, we'll talk about that at the end when we talk about the initial load problem.
Great, and we'll talk about that then. In MSIT, an interesting piece is that there are at any given point, there are over 1 million request objects in the system. And the way we found out is we run a script internally in the database. And there is a daily churn of about 60,000 requests that are created per day. What MSIT realized is that if they run delete system objects SQL job, it typically deletes 20,000 at most. So they have to end up running that job at least 3 times a day. I think, Mark, you're going to talk a little bit more about it as part of the recommendations.
Yeah. Because one thing that you can do is you can configure how often that runs. You can do that using the SQL Management Studio. If you go into SQL Agent under Jobs, you'll see each of the jobs that we provide within FIM. The temporal events job, the set correction job, and the delete system objects job. You can configure the interval in which it runs. It has a limit of only deleting 20,000 requests at every one time, and the request will also result in deleting any of the expired workflow instances that are related to that request. If you have a situation where you've gone through and accidentally triggered 1 million requests, you didn't mean to do this, you can clean this up by doing 2 things. First, you can go into the FIM portal and configure the default expiration period. You can change that period, and we document now on TechNet how you can go in and change those settings through the portal. Secondly, you can go into SQL Management Studio and change the interval by which how often you run the deleted expired system objects job. You can schedule to run every hour if you wish, and then it'll start deleting all of the objects that you now wish to expire out of the system. Another thing that we'd strongly recommend is when you think about your set definitions, avoid creating any new sets where it's a criteria-based set that includes any of these system objects, workflow instances or requests that are going to get automatically deleted. Because what's that's going to happen is you're going to have now the system running set correction and set recalculation every time we do deleting of expired objects. So that's just going to really create extra load. The final thing to think about is the performance tuning settings for the FIM service as compared to the FIM sync. Now, most of you probably have been running FIM sync for a while, or ILM or MIS, and you've tuned the SQL database that FIM sync is using for the pattern of operations that the sync service performs. The FIM service really has a different set of tuning settings that we recommend for that. And we have a link that we'll put at the end of the document if you get the slides, or just do a search for FIM best practices. And really, we've documented now a different set of settings for the FIM service database that you want to have differently from your sync database. Now, the final thing I want to talk about is our initial load behavior. So initial load, really it's a misnomer, because really what we mean by initial load is any large export operation going from FIM sync, the synchronization engine, to the FIM service. Now, we call it initial load because usually the time people encounter this is when they first install the FIM service and they need to load the FIM service database with everything they have in the metaverse. So how does this work? The FIMMA will read everything from the synchronization service metaverse and perform export operations to FIM sync. But you might also have the same kind of behavior if you make a change to a sync rule, if you're adding a new management agent. Or if you restore your FIM sync database from backup, that's going to have a different sync watermark, and the FIM sync service is going to detect that it might need to re-export operations to all the MAs, including the FIM MAs. So each one of these scenarios could result in a very large number of exports going from sync through the FIM MA into the FIM service database. Now, this is an area where we have done some work in FIM 2010 to optimize this flow. The FIM sync service at the top is talking to the FIM MA, and the FIM MA knows how to talk to the FIM service in 2 ways. The first is when we're performing export operations. So if we're bringing in data from Active Directory to the metaverse and we want to put it into the FIM service, the FIM MA will see an ad for a new user that it got from AD, and it's going to call the web service, just like any other WS transfer client, just like the portal, and say, I want to add this user. FIM service will run request dispatcher. Now, we're not going to run the workflow host for authorization, but we might run the workflow host for action workflows. We're also going to use the data access layer and write that record for a request to add a new user and the user themselves, any corresponding workflow instances for action workflows into the SQL Server database for that option, for that user. And then the FIM service will acknowledge back to the FIM MA, this user has been added. We'll then have the FIM MA add the next user, and so on and so on. Import operations take a shortcut. The FIM MA not only talks to web service, it also talks directly to the SQL Server database. That's why when you configured the FIMMA, you had to give it the parameters of your SQL Server database. Because when you're performing an import operation, we don't do a WS enumeration query. The FIMMA will go all the way to the resource database and extract either the entire objects that are of interest to the sink, like all the users and all the groups, or the deltas. What users have been added, what users have been changed, what groups have been changed since the last sync occurred. So we have that fast path that we skip over the FIM service database. One thing that we're currently working on for FIM 2010 R2, currently under development, is a similar fast path for the export operations. Because today, every time the FIMMA is told by the sync engine, export users, that's a synchronous operation. First we add Arshad, then we get the acknowledgement, then we add Mark, then we get the acknowledgement, then we add a group, then we acknowledge it, and so on, which means that the export path of doing this initial load is very, very slow. So one thing we're working on today is we're optimizing it. We're looking at using the SQL broker. We're looking at using those back channel mechanisms of sending requests into the FIM service. So when FIM 2010 R2 becomes available, take a look at the interactions between the FIM sync service, the FIMMA, SQL, and the FIM service. You'll want to be using the SQL broker, and you'll hopefully be seeing some very dramatic performance improvements about the initial load process. It should be dramatically faster in 2010 R2 than it was with FIM 2010. Some of the other things that you can do today with FIM 2010, and we document all these. The first is you can turn off SQL Server full text indexing. This actually will save you a lot of disk space during that initial load. You can do an alter full text index on a couple of tables within the SQL Server database during that load process. And then once the load is done, turn the full text indexing back on, and that'll cause re-indexing to occur on those tables. That's going to be a big performance gain you can get right there. The second thing you can do is within your FIM portal configuration is don't have the policy on during the load itself. Don't run all the set evaluations every time you're adding a user, every time you're adding a group. Instead, disable the MPRs. Set all your MPRs to disabled while the load is going on, and then once you've loaded in all your data, then turn on run on policy update on the workflows and re-enable the MPRs. That will cause all of those workflows to happen in bulk. And that's going to be a big performance gain because then you're not going to have the contention between the requests coming in by web services to add users, to add groups and so on, and the workflows. Instead, we have much better response time to FIMMA. All the users are added, and then once that's done, then we run all the workflows. Because as we saw earlier about the talk for service partitioning, we can scale out that across multiple FIM service instances. And the FIM service instances can, depending on how much load each one has, take on additional workflows. The other thing to keep in mind is the space. So by default, if you install SQL and create the SQL database, AutoGrow will be on. Now you can leave AutoGrow on. You probably want to have that on there as a safety valve, but don't rely upon SQL AutoGrow for growing out the database or growing out the log files. You want to pre-stage that. And we provide information in our best practices guide about how to do that, how to size your database for your initial load so that the SQL Server will pre-populate enough space in the FIM service database for that load operation. You also can turn off the full recovery because if you have a system failure during the initial load, Sync will want to start it over from the beginning anyway. So think about switching over to full recovery mode during the initial load and then switch it back to full recovery.
I think you want, I guess you just said it the other way around. You want to switch off full recovery mode and then come back to full recovery mode after you switch on the data.
Right, because you don't need to do full recovery during the initial load. You can only turn that on once you've completed your load process.
And as you know, the simple recovery mode only keeps data in the log file that's related to the particular transaction that is actually transacting at the moment and then deletes it from the log file. The full recovery mode keeps track of all the transactions so you can roll back to a definite point in time. As Mark mentioned, that during initial load, you already have the data outside of the FIM SQL database, so you really don't need the full recovery mode in place.
Right, you shouldn't be doing backups while you're doing that initial load because you can just go back to your metaverse. Our final set of recommendations are basically in the documentation. We've been making a lot of changes to the documentation itself subsequent to FIM 2010 RTM. It's continuing to evolve. Now I looked at some of the documents on MSDN and TechNet last night. We still have some of the older dates on the documents, but in fact we continue to be updating and revising that content. And so I'd strongly recommend get the deck, take a look at the links here, take a look at the best practice documentation on TechNet, on MSDN, specifically around search scopes, around database performance tuning, because all the recommendations we give here, the SQL commands that underlie them, the way in which we've used the profiler and so on, are all documented within the information on TechNet and MSDN. We also have a number of tools on the script box that we've written, that our MVPs have written, as well as others in our development community, our partners and so on, have written tools that help with the performance analysis. You can contribute your own findings to the wiki. We also have a forum, links to all this. There's a lot of experts out there who know more about database tuning than some of the people at Microsoft because they've been doing these deployments for many, many large customers. And they are there on the forum. We have a very lively FIM forum where we discuss performance tuning issues, best practices, the use of these more advanced tools.
So I'd like to say thank you very much for coming to the session, and I hope you've learned something new that you haven't heard before, and you have taken some nuggets that you can take back and apply at your daily job.
Yeah.
Thank you very much.
Thank you.